Hello everybody, welcome into another lesson. So today we are going to talk about what's called tetrations. So up here you have x to the second power. If you take any number, whether a variable or a number itself, raise it to a power, that's how many times you're multiplying it by itself. That's repeated multiplication, as you know what an exponent is. So x to the squared would equal x times x. X to the third is x times x times x, and then x to the first is just x. So that tells you how many x's you should have when you're multiplying it by itself. Well, there's something like it for repeated exponents when you raise a power to itself repeatedly. That's what's called a tetration. So if I have x to the x, that is repeated raising to a power of itself. That's going to be what looks like x to the second, but the power is on the top left instead of the top right. If you ever see the power on the top left, that denotes a tetration. Whereas on the top right, that's just your typical exponent. So this would be second tetration of x. That's how you would read that. Or x tetration 2. You could read that either way if it's on the top left. Now if I had x to the x to the x, I'm taking x to itself 3 times. So that would be the third tetration of x, or x tetration 3. Now if I have x tetration 1, or the first tetration of x, that's just x. So that the first tetration would look just like x to the first power. So basically a tetration turns into a power tower. So that's how it works. So let's do a few examples here of a tetration. And now, based on what you've seen, I think it's important to note that, for one thing, there is no tetration of 0 that would ever work, because that would involve 0 to the 0, and then even repeatedly 0 to the 0 to the 0. And as we know, 0 to the 0 is undefined, so there is no tetration of 0. And then any tetration of 1 is going to give you 1. Now, let's say I have here 2 tetration of 2. The second tetration of 2. Well, that's taking 2 to the second power. That's taking 2 to itself. So in this case, both would equal 4. Both would equal 4 in this case. That's the only time you would have an equal tetration to its exponent. Now, what if, on the other hand, I have 2 tetration 3, or the third tetration of 2? Well, what is that? That's taking 2 to the second to the second. So that turns into a power tower, where you're raising 2 to itself total 3 times. Well, what is this power tower? So 2 to the second is 4. This would be 2 to the fourth, which would give you 16. So 2 tetration 3, or third tetration of 2, would be 3. I mean, it would be 16. Now, what if, let's do the fourth tetration of 2. So the fourth tetration of 2, so that's going to be 2 to the second, to the second, to the second. And of course it's called a power tower because it looks like a tower. So once again, this tells you how many 2's you should have, how many times you're raising it to itself. You start with your top powers, of course, so 2 to the second is what? That's 4. So this would be 2 to the second power to the fourth. So what is 2 to the fourth? That's 16. So this would be the same as 2 to the 16th, which I know we touched on earlier. But what is 2 to the 16th exactly? 65,536. So the fourth tetration of 2 would be 65,536. Alright, let's see. So let's do the second tetration of 2. The second tetration of 3. Well, you're raising it to itself twice, so that'd be 3 to the third power. The second tetration of 3 is 3 to the third power. That tells you how many 3's you should have. That's repeated exponents to itself. Well, 3 to the third is simply 27. So the second tetration of 3 would be 27, because that would turn into 3 to the third. Now, alright, what about the third tetration of 3? So the third tetration of 3, that's going to be 3 to the third to the third. So treat this like a power tower. What is 3 to the third? That's 27, so this would turn into 3 to the 27th power. Which I don't even know if my calculator is going to give it to me, because it's going to be such a humongously large number. Wow, that's huge. Yep. So 7,625,484,987. So you get the wonderful answer of 7,625,597,484,987 for the third tetration of 3. Yikes. Let's do one more. And why don't we just do the second tetration of 10? So we're going to do the second tetration of 10. Well, that's a repeated exponent of itself, so that would be the same as 10 to the 10th power. So what the heck is 10 to the 10th power? It's not going to be a pretty number. That should be 10 billion, I'm pretty sure. Yep, that would be 10 billion. So you'll end up getting an answer of 10 billion for the second tetration of 10. So that's how tetrations compare to normal exponents. And that's all we're going to do in this course between power towers and tetrations. The next lesson we will actually evaluate polynomial functions by direct substitution and synthetic substitution. So I hope everyone has a great night. Take care.